All right, problem number 3. 10 lights are connected in series from each have equal resistances. We connect to 120 volt wall socket. They have 1.2 amps of current passing through them. What is the effective resistance circuit? So they're connected in series, so I'm going to have to start off by looking at a quick sketch of it just to get myself a feel for how this is going to look. So I go boop, 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 boop. I got resistor 1, resistor 2, resistor 3, resistor 4, resistor 5, resistor 6, resistor 7, resistor 8, resistor 9, resistor 10, and the battery. Boom, baby, got it. All right, some lights are connected in series, blah, blah, blah. They're connected to 120 volt wall socket passing through that. What's the effective resistance of the circuit? I'm going to go V equals IR. My voltage total is 120. My current is 1.2. That's my total current, right? Because it's a series circuit. All of it has to go through there. So what's my resistance? My effective resistance is 100 ohms. What's the resistance of each light bulb? Only confusion you can have here is you can say, well, what if they're not the same light bulbs? But we're going to assume they are the same. So resistance total is equal to R1 plus R2 plus R3 plus R4 plus dot, dot, dot. Getting bored of that. Resistance total would be 100, and I have 10 bulbs, each of the same resistance, so the resistance would be 10 ohms per bulb. So I got 2 answers already. 3. What is the power each bulb uses? Each bulb would be P equals I squared R, so P would therefore equal 1.2 squared times the 10 I found per bulb. And so that's going to give me 14.4 watt bulbs. D, if one of the bulbs are replaced with a different bulb, say 5 ohms, what would happen in terms of power to the other bulbs used numbers? Okay, so I'm going to take out one of these bulbs, replace with a 5 ohm bulb. When I do that, the total resistance now becomes 95 ohms. When that happens, all heck breaks loose, because now V equals IR, the voltage is 120, the current I don't know, but the resistance is now going to be 95 only, right? Because it's now got less resistance on the whole thing. So the current in the system is going to dump down to 1.26 amps. So the current is now 1.26 amps instead of the 1.2 we had earlier. So there's more current traveling everywhere, right? And so what would happen to the power in the bulbs? Well, power in the bulb is going to be I squared R. So power in the bulb is going to be 1.26 squared times resistance, which would be 10 for one of the normal bulbs. You could make the argument it's going to be, you know, about the 5 ohm bulbs as well, but I think this is good enough. 1.26 squared times 10, whoops, not plus 10. Deleting times 10, and I get 15.9 watts. So one of the odd things that happens is when you have things in series, they affect the power of everything else in the series, right? Because some of the current, some of the voltage gets used up along the way, and voltage is essentially energy. So the bulbs would all become brighter if I replace them with a lower voltage source. Sorry, lower resistance. And any one of the bulbs can replace with a lower resistance bulb. The bulbs would, in fact, get brighter. Roger that. All right, that should do the job, I think. I'll post this one.